If the coefficient of kinetic friction, mu k, between a wooden plank and a 0.2 kilogram hockey puck is 0.1, what will be the acceleration of the hockey puck if the force of 3 newtons is applied to it? Well, in this case, we need to figure out all the forces involved and then identify one more. So why don't we start with what I know? First off, I know that this hockey puck is 0.2 kilograms. Now that allows me to start talking about the force due to gravity. And that equals mass times acceleration due to gravity. And so force due to gravity equals 0.2 times negative 9.8. And so the force due to gravity equals negative 1.96 newtons. Now that's important because it also tells me what the force normal is. That is positive 1.96 newtons. Now, given this information, I also know one more bit of information, and that is this number here. And so my mu kinetic equals 0.1. Given those things, could I figure out how much force is being applied in this direction? In other words, I want to know what the force of friction kinetic is. Well, I have a force normal, and that's a given. And I have a mu kinetic equals 0.1. The thing that I don't know is force of friction, static. And that's going to be in newtons. The equation that I can use is the fun equation. The one thing I don't know is force of friction, kinetic, and that's going to be in newtons. I can use the fun equation, force of friction, kinetic, equals mu kinetic times force normal. All right, and then so I can replace numbers for letters, and my force, I do not know what my force of friction kinetic is, but I do know that it equals 0.1 times 1.96. So therefore, my force of friction kinetic equals 0.196 newtons. Now I know that there's a force applied, which equals 3.0 newtons. And at this point, I have an imbalance of forces. So now I need to figure out what my net force is. So my force net equals all the forces going to the right, and in this case it is 3 newtons plus, and why do I make the force due to friction a negative number? Because it is going in the opposite direction. So my force net equals 2.804 newtons. in this direction. This way wins. Why is that important? Because now I can use Newton's second. I can say that the force net equals mass times acceleration, and in reality that is the thing that I want to find in the end. .804 equals, I have a mass of 0.2 times the acceleration in the x. In order to get acceleration all by itself, I'll divide by 0.2. Acceleration equals 14.02 meters per second.